Hi guys! Today we're going to talk about probability, specifically theoretical probability. The probability of an event tells you how likely it is that something will occur. We use the equation probability of an event is equal to the number of favorable outcomes divided by the number of possible outcomes. Let's take a look at an example. In the first example, a bowl contains 12 congruent slips of paper, each with a different name of a month. Find the theoretical probability that a slip selected at random from the bowl has a name of a month that starts with the letter J. So the first couple of words that jump out at me are the words congruent and theoretical probability. When I see the word congruent, this just means that each slip of paper in the bowl has the same shape and exactly the same size. This means that pulling each slip of paper has an equally likely chance of occurring. The second thing is that I see the word theoretical probability. This means that I want to find out what should happen in theory without doing the experiment. So let's take a look at the example or the equation that we need to use. So again, we need to use the equation that the probability of the event is equal to the number of favorable outcomes divided by the possible outcomes. So the number of possible outcomes, we actually have a name for that, and we call that the sample space. And in this example, our sample space or number of possible outcomes are that we could pull January, February, March, April, May, June, July, August, September, October, November, or December. And so that means that our number of possible outcomes is 12. So let's start by writing the equation. So I know that I'm looking for the probability, and the event is pulling a month with the letter J, so I'm just going to put probability of J. And that's going to be equal to the number of favorable outcomes divided by the possible outcomes. Well, I know that there are 12 months, which we just looked at, so the possible outcomes or the denominator has to be 12. And the number of favorable outcomes, well, January starts with the letter J, so does July, and so does June. So we've got three possible favorable outcomes out of a total of 12. And if I go ahead and simplify that fraction down, I get 1/4. Now, when we're dealing with probability, we can denote probability either as a fraction, a decimal, or a percent. So I could have reported this also as a decimal, 0.25, or I could have written this as a percent of 25%. Now, what would happen if instead of finding the probability of selecting J, what if I wanted to find the probability of not selecting J? Well, we call this the complement of an event. That means I'm looking for all of the outcomes that are not the event that I was originally looking for. So to find the probability of not finding J, then I can write that as such. I can write that the probability of not J is going to be equal to still the total number of possible outcomes is still going to be 12, but this time all of the months that are not J are February, March, April, May, August, September, October, November, and December. So that's 9 possible months that do not begin with the letter J. So now this becomes 9 out of 12. And if I simplify that down, I'm going to get 3 out of 4. And again, we can write that as a decimal, 0.75, or as a percent, 75%. Now, notice that when we're dealing with the complement of an event, to find the number of months that were not J, all I had to do was take this total amount and subtract 3 to figure out that there were actually 9 months that did not begin with J. So when we're dealing with the complement of an event, really if we add the probability of the event plus the probability of not the event, then we're going to get 1. And I can prove that right now. Notice that we reported the probability of J was equal to 0.25, and I'm just going to use the decimal form. And the probability of not J was 0.75. So if I add those up all together, I do get a total of 1. Okay, let's look at another example. In this example, a bag contains congruent colored marbles. There are 7 green, 10 yellow, 5 purple, and 8 red marbles. What is the probability of selecting a purple marble? Well, again, we've got this word congruent. This means that each of the marbles has the exact same shape and the exact same size. That means that pulling any of the marbles in the bag has an equally likely chance of occurring. So when I look at this example, I see this list of different marbles that are in the bag. And for some reason, I always like to find what's the total amount. If I'm not given the total amount up front, as soon as I see a list, I want to go ahead and find out what that total is. So let's go ahead and do that. Okay, so the total amount that I have here, and excuse that bar for keep popping up. Okay, so if I have the total, excuse that. Let's go ahead and erase that real quick. Okay, so I know that the total is going to simply be equal to the 7 green plus the 10 yellow plus the 5 purple plus the 8 red marbles, and that gives me a total of 30 marbles. So now I know that my sample space, or my total amount of possible outcomes, is 30. And I just want to know what's the probability of selecting purple. So my event that I want to happen is purple. I want to know the probability of choosing a purple. Well, I know that my total possible outcomes is 30, and the amount of purple marbles in the bag is 5. So now all I have to do is simplify that fraction, and I can get 1 out of 6. And if I wanted to, I could change this to a decimal or a percent from this particular point. And if I went ahead and did that, then this means that this would be about 0.167 or about 16.7%. Okay, so to recap again, the probability of an event tells you how likely that something will occur. And notice that in each of the examples, we wanted to have the probability of each event to have equally likely chances of happening. And that's why we kept seeing that word congruent in each of the problems, because that will assure us that each of the events is equally likely to occur. And again, if we wanted to find the probability of a complement, we just find all of the possibilities of all the probabilities of the event not taking place. So I hope that was helpful. And if you have any questions, then please let me know. Thank you.